Hi everyone, welcome to this pre-recording of my Gartner IOCS talk, Gaining Operational Maturity for Effective Docker and Kubernetes Implementations. I'm Neil, the CEO of Portainer. You have my LinkedIn QR code here on the screen, should you wish to connect with me. Today we'll explore how operational maturity critically influences your success with containers and Kubernetes. We're going to discuss the challenges organizations face when adopting these technologies without sufficient operational readiness. And we're going to introduce the Portainer self-assessment tool to help you evaluate and improve your operational maturity. Containers and Kubernetes offer agility and scalability, but introduce complexity as well. Without operational maturity, these technologies can create more problems than they solve. There are more and more public examples of organizations complaining about their failed containerization projects, and most of these come back to gaps in operational maturity. Organizations unprepared operationally face significant risks impacting business continuity and reputation. Containers and Kubernetes themselves are transformative, but they are not magic bullets. And definitely adopting Kubernetes is a lifestyle choice. Are you prepared to make that choice? When you are making a decision to adopt Kubernetes, you're making a decision to invest significant sums of money in tooling, people, and operational change. Are you ready for that? Operational maturity is essential to unlock the full potential of Kubernetes. If you do not, Kubernetes can be an Achilles heel. Lack of maturity can lead to security breaches, downtime, and loss of trust both within the business and with your customers. Worse, the technology can be deemed a failure, rollout stopped, and hindering your ability to compete in the market. Containers enable rapid development, deployment, and provide consistent environments, but they require significant changes in how we manage and operate these same applications. Have we fully assessed our readiness beyond our initial enthusiasm? Like it or not, Kubernetes will absolutely require you to invest in people, either new skills in existing people or new hires to buy in the missing skills that you require. There is absolutely operational overhead when you are looking to deploy a container platform, and day two operations cannot be understated. Again, there are massive positives in adopting containers. However, there are operational realities that you have to address. So operational maturity involves more than adopting new tools. It's about your people and your processes too. Each pillar in operational maturity supports the others. If you ignore one, it undermines the overall maturity. You have to have an honest evaluation to identify your areas of improvement. There's no point lying to yourself saying, yep, we're all good in this area when you're not. It will bite you. You need to understand the skills of your people, the structure of your IT support team, the tools that you have and the tools that you will need, and the processes you have in place and will need to put in place to support containerized applications. The first challenge is insufficient platform engineering and DevOps skills. You absolutely need to have a very specific skill set to support and manage Kubernetes. Containers are very different from virtual machines. They require new skills, revised skills, different skills. And assuming teams can manage without upskilling is a very, very risky bet. Misconfigurations, security compromises, downtime, constant troubleshooting, these are the things that you can expect to see if you have a team that does not have the skills to operate the platform. So the skills gap is very real. And by the way, it's also very difficult to find skills in the market to operate Kubernetes. So you have on one side, the challenges of upskilling and the need to upskill, and on the other side, the market shortage in the skills. but again, you have to address it. Again, operational failures, increased incidents, disadvantage competitively over other organizations that are better prepared to support their Kubernetes environment. Losses in productivity due to inefficient problem solving. The mean time to resolution often increases dramatically based on the level of complexity in your platform. If you have a very, very complicated Kubernetes setup, whenever you have outages, the time it's going to take for your engineering team to find the root cause and resolve that root cause is going to be elevated. Interesting enough, there is a recent HashiCorp survey, and the link to that is in the bottom of the slide here, that found 64% of container projects are either stalled or compromised due to skills shortages. So challenge number 2, organizational structure constraints. In the world of virtual machines, we embraced the term a VMware admin or a VM admin team. This very quickly became the virtual platform team. That similar construct exists now in a Kubernetes world. If you don't, and often in the early onset adoption of containerization, the person who introduces the technology into the business is the person responsible for supporting it. And if you have multiple teams introducing the technology, you might have multiple people supporting the technology. Well, you really want to centralize that back. You have fragmented responsibilities, blur accountability. Who is responsible for ensuring the platform is up, delivering to SLAs, delivering to OLAs, and generally providing the level of service that the business expects? Siloed departments hinder communications and efficiency. You need to have someone who owns and manages the platform, who is responsible for the platform, who is responsible for ensuring the platform is safe and secure, who is responsible for ensuring the platform is performant. There has to be a team. Now, in today's world, that is the platform engineering team. And again, it's very similar to what we did when we adopt virtualization, where we had a VMware or a VM platform team. Similar thing. If you have a shared responsibility team, this whole you build it, you support it construct that DevOps introduced, there is a real lack of accountability. There isn't one team responsible for ensuring the system is operational. You really want to assess and realign your roles for clarity and efficiency. We need dedicated teams with focused expertise to deliver faster resolutions. If there is a constraint in the market of Kubernetes skill set, then trying to hire 20 of them to have a vast array of teaming is significantly harder than hiring 3 or 4 for a dedicated support team. Be careful of engineering leaders engineering your platform in a vacuum. It's very, very common, and over-engineered solutions almost always end up in complexity. And remember, complexity directly impacts resolution time when you have issues. So be very, very careful letting your engineering leaders have free rein. You want to understand the level of technical risk that you're adopting when you are adopting a Kubernetes platform. Challenge number 3, incorrect tooling. It's really important to have the right tools to support your environment. Kubernetes itself is not a complete turnkey platform. I like to describe Kubernetes as the engine in a vehicle. An engine alone is useless. The entire vehicle is what transports you around. Kubernetes, without the ancillary tooling around it, is very, very difficult to achieve operational readiness. You need tools focused on monitoring container-based applications, monitoring the highly dynamic Kubernetes runtime environment, troubleshooting, securing, and access. There are over 2,000 tools in the CNCF landscape. Which of these do you need? Do you need all of them? Do you need some of them? Which ones do you choose? And the tools that you choose, are they going to empower your team, or hold them back. From whose perspective? From the engineer's perspective or from the business's perspective? You have to have the right tools. If you don't have any tools, you're going to have manual processes. Manual processes are hard to replicate an outcome. They're also very inefficient. If you have the wrong tools adopted, you may find that you are wasting money as the vendor disappears. Vendors come and go. Obviously, the ecosystem is full of startups. But even worse, if you have to go and license 9, 10, 15 commercial open source tools, the cost of that is quite astronomical. If you have insufficient monitoring, you really are blind as to how your application and the platform is performing. You need to have the right tools. And don't forget your internal users. Internal users are the day-to-day operators of the platform. Tools that are beyond their operational understanding can lead to mental fatigue and mistakes. You need to ensure that the tools that you select are aligned to the knowledge and capability of your team. There's no point having a perfect tool that your team cannot operate. When it comes to taking your legacy applications and moving them into containers, you have to be very, very certain that this is the right choice. Containers are not a one-size-fits-all solution. You need to be absolutely certain that your application is horizontally scalable, can start and stop at random as Kubernetes or Docker decides to reschedule the application on an alternate host in the cluster. You need to make sure that your application can run in a stateless deployment. Containers by default are stateless. If your application expects to be able to write state and have that state retained, you need to ensure that you can work around that. If you have really complicated dependencies, cross application communications, if you're used to these being at nano speed, i.e. on the same physical server, and you now horizontally scale them, how will that latency impact your application? Moving your applications to containers is valuable, but you need to understand the time and investment to do so. You can't just use a tool and say, I want to containerize this application, next, finished. There is no such thing. Whilst we had that in the virtualization days with P to V converters, no such thing exists in containerization because it is a largely different concept. You have to fracture your applications into microservices and then have them all communicate in a 12-factor architecture. If you do want to experiment with your legacy applications, maybe consider applications that are lower in criticality to the business, understand the impact of horizontally scalable applications on your application, get a really good grasp of how to triage, monitor, and scale, and then move to more critical applications. Again, there are really high potential of performance issues if your application has not been designed to be scalable horizontally across the environment. And so you have to be aware of this because there might be unstable, I would say, performance issues that impact the end user. The end user might hit your system and it be routed to a host where the front end container is on the same host as the back end container, and so performance is actually really snappy. They might then come back a few minutes later and now hit the application front end on another host, and that host now has to have cross-host communication to middleware or back end, and now there is introduced latency. And so the user was like, wow, it was fast 1 second and now slow the next. You have to be really careful of quick fixes to this problem because you can introduce technical debt. So you actually have to understand the root cause and address the root cause. Don't just put band-aids on. And often it might be quicker and easier to actually re-architect your application and or replace it versus trying to push it into a container where it hasn't been designed for that. Not all applications are worth putting in containers. Choose wisely. So If you have low operational maturity and you go live with a Docker or Kubernetes environment, you will experience issues. Frequent application and or platform outages, extended outages, outages that get blamed on the technology because people don't know any better, fear to perform updates. If you don't know what happens when you update Kubernetes, do you think you'll update Kubernetes? Probably not. Security vulnerabilities, unpredictable performance, engineers spending all their time learning versus doing, engineers spending their time fixing issues versus running the system, projects taking substantially longer than expected to implement. It's common to hear projects that are taking 9, 12, 18 months versus the promise of 3 to 6 months. Technical understanding inaccuracies. Many people think that namespaces in Kubernetes give you solid isolation between your applications. They don't. They give you domain name isolation, but at a TCP level, you have full communication between your namespaces. Monitoring tool costs spiral out of control. The amount of people who are talking about 10,000, 100,000, $1 million Datadog bills just because their team don't know any better and they are simply sending noise from the platform. And remember, you pay for ingest, and all of this noise equals dollars. Sprawl of the environment. If a developer is not constrained to resources, then they're going to ask for everything. If they keep asking for everything, eventually your platform will need to be scaled. Your engineering team will scale it, and it's a vicious cycle. You should have quotas and restrictions applied so that you are accurately controlling access to resource. If your engineers want to automate everything on day one, they are wasting your time and your money. You only automate tasks that you perform on an ongoing, regular basis, and where the time saving of automation significantly outweighs the time of actually completing the task manually yourself. You don't have to automate everything just because. If you have hard walls between your devs and your ops team, that's a real problem. Ops are there to serve the dev team. The ops team should feel obligated to deliver the level of service and the level of experience that the dev team want, not what the ops team want to deliver. Again, the devs are the internal users of the platform. No centralized management of your platforms. If you have to log into multiple tools to get a view of your overall landscape, something is wrong. And if you can't see the overall security posture, the access control, the role-based access control, the governance of the environment, if you can't see that from one central place, you've got the wrong tooling. So here at Portainer, we built this operational maturity self-assessment. It has 4 pillars, and you are required to go through and answer a bunch of questions that will help you understand where you are in the operational maturity standpoint. It'll also ask you where you want to be based on the types of applications that you need to deploy. So the red line in this picture is where your organization should be because of the types of applications that you plan to deploy and deliver on your platform. The green boxes are the level of maturity that you currently have in your team. Now, technical skills, operational readiness, application readiness, and tooling. And the orangey yellow are the gaps that you have to close in order to deliver to the red line, which is, again, the level of maturity that you need to successfully run your application in production. If you go into production with an application at the red line and you operate at the green line and you do not address the orange gaps, you will experience the issues that I highlighted previously. So on the screen now, you'll see a QR code. Scan this QR code. This will take you to the download link for our operational maturity assessment. Complete the maturity assessment. Have each member of your support team complete the assessment, at least self-analyze their own skills. Look at the lowest common denominator in regards to skills. Again, you don't want to assume operational maturity because one person has a high level of technical skill. You need to make sure that you have your own internal skills resilience. So look at the average or the median skill level. Use the findings to prioritize your actions and your investments in both people and tooling. And be aware that operational maturity is essential for your success. Ignoring gaps in maturity is a recipe for disaster. Don't let your assumptions hinder progress. Take action today. So, thank you for listening to my talk. Happy to answer any questions that you might have. Again, you have my LinkedIn QR code. Connect to me, and if you have any questions, I'll be happy to answer them. Thank you.